Okay, hi guys. So in this lecture we'll be discussing about SN-NGP or SN neighboring group participation. Okay, so we'll be discussing about SN-NGP type of reaction, where NGP means neighboring group participation. Okay, so it is also called ankemeric assistance. Ankemeric assistance. Okay, so let's take one example for understanding it. So suppose we have this ring and this has PHX and hydrogen, and we have hydrogen and Cl here. So what happens when it is placed in H2O? So what will happen is, as you know that this is a nucleophile, as it has two lone pair of electrons, so this will go in SN2 mechanism, that this nucleophile will attack this carbon atom and this Cl will remove itself. So what will happen is, the PHS gets a positive bond here, and this is actually a state of transition. In the transition mode, so we will have a bond formation here and a bond breaking here, and H is already attached on it, and we have H here. Okay, so this is the transition state. After the transition state, this is also the rate determining step. What will happen is, we would have something like this. PH is bonded to S is having positive charge, we have a H atom here and a H atom here. So what will happen after this is, H2O part will take care, and OH minus will actually either can attack on this carbon atom or on this carbon atom, so as either this bond breaks or this bond breaks, and the S actually regains its electron in its orbital. So it can either attack this carbon atom or it can attack this carbon atom. Okay, so what will happen is, we will have something like either this, and also one point is, we would have inversion of configuration, just like in SN2 reaction it takes place. Okay, so we would either because of if let's say first is here, so first product is formed here when the OH attacks on this carbon atom. So what would happen is, H should come here, OH will come down the plane, and PHS will come here and H here, and other compound will form if the OH minus attacks on this carbon atom. So it would form something like, H would come above the plane, OH below the plane, and again PHS would come here and H would come here. So in this way, this is the second point, this is the second type of attack. So in this way, racemization takes place in the reaction mechanism. Okay, we'll take another look with some second example. Let's say we would have something like this. PHS is there and HCl is there. So in this case, would the NGP mechanism take place? So the NGP mechanism will not take place, as we have mentioned that it is a SN2 type of a reaction, in which nucleophile will attack on the opposite side of the leaving group. Okay, and in this case, the nucleophile, this nucleophile and the leaving group are attached from the same side. So NGP mechanism would not take place here. If you remember the SN2 mechanism also, when OH minus was attacking or any other nucleophile was attacking, it was attacking from the backside of the carbon or the anti side of the carbon from which the already existing leaving group was attached, right? So in the same way, it follows the SN2 mechanism in the RDS, hence it would attack from the opposite side of the leaving group. But the only difference in both the type of reaction is in SN2 only one nucleophile was there, but in this case the neighboring group participation of a nucleophile will also come into the picture, which will actually force the halogen atom to leave the compound, and then again the positive charge on the neighboring group participated nucleophile will be removed by again attack by a second nucleophile. In this case, in the above case, OH, just like in OH minus was actually the attacking the second nucleophile, in which even that nucleophile will be attacking on the anti side of the neighboring group that has participated. In that case, PHS plus had been participated in the intermediate state, hence OH minus again will follow the attack from the anti side of the PHS plus. Okay, so I hope you are following this. Okay, so let us write the characteristics of this reaction. Every reaction, every mechanism which we discuss, after the discussion we would try the characteristic of the reaction just to document it and to have a clearer picture for the rest of our journey. Characteristic of reaction. So what are the characteristics of the reaction? Characteristics of the reaction are means it is a first order reaction. It is a first order reaction. Second is it is a very fast reaction. This fact is experimentally verified. It is very fast. Third is NGP step is the conversion of configuration. So NGP step is the conversion or inversion, better, inversion of configuration. Fourth one is condition for NGP is the presence of good leaving group and a nucleophile on the same compound, and nucleophile and leaving group must be anti to each other, right? So condition for NGP is the presence of good leaving group and nucleophile on the same compound. And nucleophile and in this condition only I am iterating a point that nucleophile and leaving group must be anti to each other. Okay, so let us write the mechanism for the following NGP reaction. So question is write the mechanism of the following. So we have something like this. CD2 and it is we have a solvent, water as a solvent. Okay, so what would happen is, let us see for what would be the products of this reaction. The product would be CD2 and OH, and other product would be CD2 CH2 OH. Okay, so now let us see how these two products are formed via mechanism. So let us see the mechanism. So in mechanism what would happen is we have something like this, CD2 and Cl. So what would happen is this will have NGP on this and Cl would be leaving. So this would be a SN2 step in which bond formation would be there and bond breaking would be there. Okay, this is a transition phase. So after this phase we would have something like this, where we have plus charge on CaS attached to 3 carbon atoms. Now what will happen is the water will come into the picture. This was the first step. In the second step, water would actually either can attack this carbon or can attack this carbon. So let's for now consider that water attacks the first carbon. So attack on first carbon would result me a compound something like this. This would also be inverted. So this would be come out to be CD2 and CH2OH. And if it's attack on second carbon would yield me something like this. Okay, so these are the final two compounds formed after the SN-NGP mechanism. Okay, so let us do a third example wherein we have to do the same SN-NGP mechanism. Okay, let's for an example change this to Na2S. So what would be the reaction, what would be the compound after this? So the first compound which will be getting after this would be the S minus, which actually be attacking on this carbon atom, and this would be a again SN2 step. Okay, so we will have something like this as the first step, that the bond formation between S and C would be there, and the removal of Cl and C, or the breaking of Cl and C bond would be there. So we would have something like S minus here. So now what would happen is in the second step, again this nucleophile would have a SN2 mechanism. The first step was SN2. Again in the second step, the SN2 mechanism would take place. Again we would have something like S 1 2 3 4 5 6 carbon atom position. 1 2 3 4 1 2 3 4 okay, 5 only. Okay, so we would have something like this. This and this. Okay, so 5 membered ring would be formed with the NaCl or 2 moles of NaCl being formed. Okay, so this would be the end product. Okay, so this is also an example of SN-NGP. So I just slightly twisted the concept by having a reagent as Na2S. Okay, so second example would be, suppose I have something like this, and we have H2O attacking on it. So what would be the product form? Product form would be this. And how is it forming? Let's look into the mechanism. So this is a nucleophile, so it will attack on this via an SN2 step, and this bond breaking formation and bond breaking and bond leaving, bond formation and bond cleavage would be in the intermediary step, and the resultant product or the intermediate would be something like this. Okay, this was the carbon atom here, and this is the carbon atom here. I think this is the, oh, okay. So, and this is the second carbon, this is the second carbon. Okay, now what would happen is, in the second step, it would be attacked by H2O, and finally we would have something like this as our product. Okay, let's take a look at the third more examples. We have phenol, and on phenol we have CH2. This is the isotope of carbon, molecular weight 14, and OTS is on this carbon atom, and CH3O minus is there in the presence of CH3OH. So what would happen in this reaction? You know that OTS minus is a great leaving group, right? So what would happen is, this CH3O minus would actually, this is the most acidic hydrogen, right? So, and what will happen is, it will take up this hydrogen atom from here, okay, and CH3OH would be formed. And the reason why this reaction should go in the forward direction is, phenol or this type of group is more acidic than primary alcohol, hence this reaction would go forward. Now what happens? Is this a final product? No. What will happen after this? After this, let us see in detail. We have something like this. So the O minus will actually donate its electron here, and resonating structure would form, in which we would have something like this structure. Obviously I missed, this is CH2, C14H2, and OTS. Okay, so here what would be there is, we will have negative charge here, this would be the product, and here we have CH2, C14H2, and OTS. So again NGP would form here, wherein it will attack on this carbon atom, and OTS will actually leave as a part of nucleophilic attack, because it's a good leaving group. So what will happen is, next we would see something like this structure. Here, so now what would happen is, the benzene ring would again like to regain its aromaticity, so this bond cleavage would take place, or better, we already have CH3O minus in place. So what it will do is, it will again, as a nucleophile, it will again attack on this carbon atom, and as a result, oh sorry, I beg your pardon. So now SN1 reaction will actually take place. So how SN1 reaction would take place is, you know that we have CH3OH as our solvent. So what will happen is, as a part of SN1, this benzene ring has to regain its aromaticity. So what would happen is, this bond cleavage would happen, as I was saying in the previous step. So this negative charge would come here, and CH2 14 along with CH2 positive charge formation would be there. Okay, so now what will happen is, now actually CH3, let me make the resonating structure first. So in the next step, what would happen is, we would be having and again CH3OH will actually attack on this forming something like O minus is here. Aromaticity is regained. Oh, it was already aromatic. The benzene structure was regained. 14 carbon here. CH2 OCH3 forms here. Okay, and then as a result H plus was released from CH3OH, and again O minus will take this H plus to form OH again. So again it's a base induced reaction, OCH3. This would be the final product formed. Okay, so with this we come to an end of this lecture in which we discussed SN-NGP. So before that, let me just introduce one more concept of SN-I reaction. So in the SN-I reaction, what happens is, suppose we have, this is an important example. This type of examples are asked in JEE level competitions. So PHH. So in this case, suppose we have SOCl2. So instead of attacking this invertedly, because it's a SN2, what we will have is, it will not be inverted, it would be retented, or retention of configuration will take place, and as a result SO2 and obviously HCl would be released. So this is called Darzin's process. And in this case retention of configuration takes place. But if we on the other hand reacted this with the SOCl2 in presence of pyridine, okay, let me write down the total all the reagents. So if we have reacted in the presence of SOCl2 in presence of pyridine or PCl5 or PCl3 or PBr3, again in presence of pyridine, or Pi3 or PBr3 or PCl3 or something like P plus Cl2 or P plus I2, then the product would be this. Cl would be actually be inverted because of the SN2 mechanism. So with the SOCl2, what we noticed that the retention of the configuration took place, and this was Darzin's process, and this type of reaction is actually called SN-I reaction, SN-I mechanism. This takes place through SN-I mechanism. Okay, so in the next lecture we will be discussing about hydrolysis of ether. Till then, good luck and goodbye.